So let's do this in turn. Heat pumps. So heat pumps were the single biggest effect on cutting our carbon footprint. About half of the footprint was cut with the heat pumps, about 20 tons per year, saving us about $3,000 a year. It costs us about $26,000 to put the heat pumps in. They pay for themselves in about 9 years. That's a return on investment of 9%, and that's 9% after tax. So if you were to compare that to a pre-tax or taxable investment like in the stock or bond market, it would have to be something like 12, 15, or even 18% pre-tax return to be equal to a 9% after-tax return like I'm getting on heat pumps. And that is with no investment management fees, no volatility, and index for inflation. So in my opinion, a much better deal than investments in the stock market. Now, the heat pumps I'm talking about here are air source heat pumps, not geothermal or ground source heat pumps. We had a quote for geothermal on our house. It was $98,000, or 4 times the cost of doing air source heat pumps. Geothermal is one of those things that makes energy sense, but does not make financial sense. So these are our heat pumps, and if you're thinking to yourself right now, oh, they look just like our AC units, you're right, they do. And in fact, they perform exactly the same way that AC units do, in that they cool your house in the summertime. But in the wintertime, the circuit is reversed, and instead of pumping heat out of your house, they pump heat into your house. And when they do that, they heat with 4 times the efficiency of a furnace or a boiler. 4 times is a huge change in the efficiency of heating your house. They cool with the same efficiency as an AC unit. So how does a heat pump work? Well, most people think they're unfamiliar with a heat pump, but it's not true. Everyone is very familiar with a heat pump because a heat pump is in your refrigerator. And a heat pump removes the heat from, say, your milk and pumps it from the inside of the fridge to the outside to the kitchen. That cools the milk down and heats up the air in your kitchen. So if you've ever put your hand down behind your refrigerator, it's warm. That is the heat that was removed from your milk. And I remember my mother, when I was a kid, would actually start trays of seedlings on top of the refrigerator because it was warm up there, and it would start the seeds earlier. On a larger scale, a heat pump or an air conditioning unit cools your house the same way. It pumps the heat from inside the house to the outside of your house. So if you were to put your hand over the air conditioning unit in the summertime, it's hot. So it may be 80 degrees outside in the summer, but it's 110 degrees over the air conditioning unit. Now, if you reverse that circuit in the wintertime, you will move heat into your house, warming your house up, but the necessary effect is you cool the air still further outside. This is counterintuitive because it's cold out. How can there be any heat in the air when it's so cold? Well, a physicist will tell you there's still plenty of heat in the air, and you can move that heat into your house as long as you cool down that air outside. And this is what happens. I'm showing you here my heat pumps. On the left is me holding an infrared thermometer, and I'm measuring the air going into the heat pump. It's 4.7 degrees Fahrenheit. It was a very cold winter day. You can see the snow on the ground. I'm wearing a ski glove. On the right, though, you can see the exhaust side of the heat pump, and you can see the temperature is minus 19.6 degrees Fahrenheit. It's unbelievably cold. It's so cold, if you put your hand over there, you get frostbite. And this is showing you that the air outside is being made colder still by the heat pump, and that heat is being removed from the air and pushed into the house, making the house warmer. This is how heat pumps work to heat your house, even in cold weather. That was a ducted heat pump. So those connect to ductwork in our house, which existed already. And that ductwork moves the warm air around the house in the winter and the cool air around the house in the summertime. There is an alternative, which is a ductless mini split heat pump, or a wall-mounted or a ceiling-mounted heat pump. And this we have at our rental property. You can see the outdoor unit on the left there. These are made by Mitsubishi. And the indoor unit, we chose the ceiling units, which are up there in the ceiling. Usually these have wall-mounted or floor-mounted units. I prefer the look of the ceiling-mounted units. They're a bit more expensive, but I think they look much nicer than the wall-mounted units. So for heat pumps, for details on which ones we bought and what the subsidies are and the zero interest financing, it's all in chapter 2 of the book you'll get at the end. And I don't really recommend geothermal heat pumps or ground source heat pumps. They will cut your carbon footprint, but they are far too expensive compared to air source heat pumps. They really don't make financial sense. Also, I recommend you leave your furnace in place. we still use our old oil-powered furnace on 20 to 30 days a year on those bitterly cold days when it's below about 20 degrees Fahrenheit outside. We still burn about 300 gallons of heating oil a year, down from 3,000 gallons a year before we put the Fab 4 in place. And the carbon footprint of that 300 gallons is more than offset by the excess solar power we export to the grid. And that solar power displaces a fossil fuel burning power station, and that's why it has a negative carbon footprint.